Hello, this is Mr. Kinyanola, and I'm going to teach you about systems of linear equations when both equations equal y. A system is just a couple of equations, more than one equation, where that represents lines that meet at a certain point. So this is a line, and this is a line, and our job is to figure out the address or the coordinates where those two lines will eventually meet. Now, in this situation that I'm going to teach you about today is when both of these equations both equal y. That's what they have in common. If they both equal y, then logically they equal each other. So if they equal each other, then we could write it out that they actually do equal each other, like this. So y equals negative 6x minus 7 and y equals 5x plus 15. So we can write negative 6x minus 7 equals 5x plus 15. We just get rid of the middleman. That middleman is what connected them together, and we'll just put those two together. All right, now we got rid of one of the two variables, the y's, and we're just going to solve this equation with one variable, an x. So what we're going to do is get all the variables on one side. So I'm going to take this negative 6x, and the opposite of negative 6x is positive 6x, and I'm going to add that 6x to the other side of the equal sign. So some teachers like to write a little line right here just so that we know that we're putting things on both sides of that line. And the negative 6x plus the 6x cancels out or eliminates each other. 5x plus 6x added together is 11x. We're going to bring down that 15, and we're going to bring down this negative 7. Now what we're going to do is we're going to subtract this 15 from both sides because we want to get all the numbers together. And negative 7 minus 15 is a negative 22 equals, I'm going to bring that down, bring whatever we have left over down, which is the 11x. Since this 15 and negative 15 cancel out, so we have negative 22 equals 11x. This is 11 times, if there's no operator there, it's times or multiplied. The opposite of multiplication is division. So we're going to divide both sides by 11. So then we'll get our answer for x. Negative 22 divided by 11 is negative 2. So I'm just putting the x on this side, on the left side. So we have half of our answer. We have the x coordinate. Now we need to find the y coordinate. Here's how we find the y coordinate. We take this negative 2 and we plug it into any one of these two equations. I'm going to plug it into this top one. Doesn't matter. We'll get the same answer. So y equals negative 6, and I'm going to put a parentheses instead of just the times. Parentheses negative 2 minus 7. Zoom in on over here. Okay, so negative times a negative is a positive. So y equals positive 12 minus 7. Y equals 12 minus 7 is 5. So our answer is negative 2, 5. And the great thing about systems of equations is that we can always check if this is really correct. But before we check, this negative 2, 5 is our answer. It's the address, it's the coordinates of where these two lines, if we ever graph these two lines would meet at negative 2, 5 on the coordinate plane. So let's check this answer. Negative 2, 5. I'm going to plug it into the second equation, the one that we didn't use. And I'm going to write y equals 5 times negative 2 plus 15. Oh, I'm not going to plug in y. I'm going to put this y. Our y is 5. So 5 right there. So this goes here, and the negative 2 goes here into the x from our equation here. 5 times negative 2 is negative 10 plus 15. I'm going to bring down this 5. Negative 10 plus 15 is 5. And it works out. 5 does equal 5. Now let's check our answer on the other equation. I'm going to plug in 5 again. Equals, and I'm going to plug in our negative 2 in our answer. Let's just highlight this so that we know that this is our answer. I'm going to plug in this negative 2 into this x for this first equation. So negative 6 times negative 2 minus 7. And let's see if this really does equal 5. So negative 6 times negative 2 is positive 12 minus 7. Bring down that 5. 12 minus 7 is 5. So both sides do check out. 5 equals 5 for the one equation, 5 equals 5 for the other equation. So then that's when we know that negative 2, 5 is really our answer. All right, so let's try another one. Let's try this one. Okay, so if you notice, both of these equations, what do they have in common? They both equal y. So since they both equal y, we can set them equal to each other. So if you want to pause this and try this on your own instead of just watching me, and then press play whenever you get the answer and see if you get it correct, then do that. Or you can just follow along. So I'm going to take negative 7x plus 14 from the first equation and set it equal to 5x minus 22 from the second equation. We can do that because both equal y. Now I want to get all my variables on one side. So let's draw this little line. I want all my variables on one side of the line and all my numbers on the other side of the line. So let's do that. I want to put up my variables on the left side. You don't have to. You could put your variables on the right side. I'm going to do the left side because I'm left-handed. So I'm going to subtract this 5x and subtract 5x from both sides. You want to make it equal. So if you take away from here, you want to take away the same amount over here. Negative 7x minus 5x is negative 12x. I'm going to bring down that 14. This cancels out. I'm going to bring down this negative 22 on that side. Okay, so I have all my variables on one side. I want to get my numbers on the other side. So the opposite of plus 14 is minus 14. So negative 22 minus another negative 14s would equal negative 36. I'm going to bring down this negative 12x. Look at all these negatives. All right, and then the opposite. So remember, when there's no operator in between, that means multiplication. It's an invisible multiplication. I'm going to divide both sides by negative 12. So x equals, and two negatives make a positive. 12 goes into 36 3 times. All right, now I'm going to take this 3. I'm going to use this 3 to help us find y, because we will need an x and y coordinate. All right, so let's zoom out. I'm going to take this 3. I don't really want to deal with a negative right now, so I'm going to plug it into this one right here. So y equals 5 times 3 minus 22. And this is going to help us get our y. 5 times 3 is 15 minus 22. So y equals 15 minus 22. This negative is the larger number, so our answer is going to be a negative. 15 minus 22 is negative 7. So let's write our answer as 3, negative 7. All right. Now feel free to check this by plugging both of these numbers back into both equations and make sure they check out, just like we did over here. Okay. Let's see this last example. So if you want to pause the video and try this on your own, and then press play and fast forward and see if you get the answer, or just follow along. Either way, whichever helps you learn better. All right, so both equal y. So I'm going to set them equal to each other. 2x minus 4 equals 3x minus 3. I want to get all my variables on one side. So this time I want to put all my x's on the right side just to switch it up. So I'm going to subtract this 2x on this side, subtract the 2x on this side, and check this out. Here's a shortcut. I'm taking my variables and bringing them to the right side, so I'm going to subtract that in here. So if I'm going to bring it to the right side, I'm going to take all the numbers on this side and bring them over here. So I'm going to take this negative 3, I'm going to add it away to over here to the left side. So, and let's see if they do cancel out. So 2x minus x, they cancel out. Negative 4 plus 3 is negative 1 equals 3x minus 2x is just the 1x or just x. And negative 3 plus 3 cancels out. Look how quick that was. So x equals negative 1. We're halfway there. So we have our x value, our x coordinate. Now we're going to plug this back into one of the variables. Doesn't really matter. I'm going to use this top equation over here. So y equals 2, and this is our x value. So I'm going to plug it in or substitute into x minus 4. So y equals 2 times negative 1 is negative 2 minus 4. And y equals negative 2 minus 4 is negative 6. And so our answer, two negatives, is negative 1, negative 6. And if you want to check your answer again, let's take these two variables, or let's take these two answers, our x and y coordinates, and plug it into both equations and see if it checks out. Let's actually do it right here. So I don't trust myself. Sometimes I doubt myself. So let's see. Let's take away that doubt. So I'm going to plug these two into the first equation. So our y is negative 6 equals 2 times negative 1 minus 4. So I'm substituting these two, the x into here, the y into there. So negative 6 equals 2 times negative 1 is negative 2 minus 4. Negative 6 equals negative 6. So it checks out for the first equation. And then let's just write it over here. I'm going to take our second equation and plug in or substitute negative 6 equals 3 times negative 1 minus 3. Ran out of space over here. Okay, 3 times negative 1 is negative 3 minus 3. Negative 3 minus 3 is negative 6 equals negative 6. Works out. Both of them check out. If these two numbers aren't the same numbers when you check, then you did something wrong, and then you will have to do these steps again. So you get two numbers that will check out when you plug them back in. So yeah. So these two lines right here, when they cross paths, they will meet at negative 1, negative 6. All right, that's it. That's how you solve systems of linear equations when both equations equal y. Thanks.